In this section, I'm going to look at the combined effects of two independent variables on a single dependent variable. So in our example here, we're going to look at the impact of pH and temperature on the activity of an enzyme. This is very much in line with what you've been doing in the lab this week. And the statistical task or statistical tool we're going to use is Two-Way ANOVA. So the only difference between a two-way ANOVA and a one-way is you're looking at multiple factors simultaneously, and that's really useful, and it really helps us design quite elegant experiments where we're looking at the impact of more than one factor at the same time. Importantly, it also tells us about any interaction effects between those two dependent variables, in this case pH and temperature, but it could be anything. Okay. Right, so let's get started. I'm going to start with 6.2.1. Again, we're going to get our data from a URL. Let me just copy this, make it a lot easier. Start with our studio, wherever that's gone. I'll have to boot it up here, hang on. Right, so here's where I left off with the last video. I'm going to create a new script file. Let's call it activity. And you can see actually I've been here before, so I'm just going to override it. And I'm going to paste that in. I'm going to clear my environment to make sure I'm only looking at this data set and any associated variables. So there you go, there's my activity data. There's 300 observables. Let's take a look. There you go. Group, pH, temperature, activity. The group is just a number representing a given experiment, which I've then consolidated. Okay. Now you can see in my activity column, there's a few funny things going on here. I've got values for my activity. That's great. So these activities represent the absolute change in absorbance over time. And then I've got things like this, error. So this is no good, is it? I've got some string data amongst my numerical data. I've also got a few gaps. Don't like that either. And somewhere else, yeah, I've also got a few negative numbers, which I don't want. I want my activity to always be positive. So before I start analyzing this data, I'm going to need to tidy it up a bit and get rid of anything which I deem to be non-numeric or negative in this case. So how do I do that? Well, I can run that line as well. That'll give me the same thing. I need to think about this. Okay, before I start to clean, I'm gonna set those pH and those temperature columns as factors, just like I did in the previous example. This is how I did it. Activity. I'm going to call my data frame. I'm going to call the column. I'm going to do as.factor. Activity, there we go. I'm going to do the same for temperature. Oops. Okay, so that's going to make sure that those columns are treated as factors. That's not going to change anything that you can see, but when it comes to performing your ANOVA, it's going to make sure that it works without an error. Let's get rid of these horrible error values which are in my column, my activity column. The way I'm going to do that is I'm going to force this column to be numeric, and that should replace these error strings with an NA, which I can do something with. I can get rid of those then. Okay, so I'm going to force numeric for activity column. To do that, I'm going to call my activity column. Oops. And I'm going to use the function as.numeric. And I'm going to call the column again, activity data activity. Okay, so it says NA is introduced by coercion. If I do head activity data again, oh, not heat, head. you can see that that error value has now gone to an NA. So anywhere where I've had a string in my activity column, it's replaced it with NA. Now I actually want to remove any row with an NA in it. Okay, remove NA values, because I don't want to include those in the analysis. Actually, it will be okay to include them, but for sake of cleanliness, I don't want to include them. So to do that, we're going to do activity data. I'm going to call the whole data frame this time, and I'm going to use na.omit. Okay, it's just another function, and I'm going to do it on itself. There we go. That should be okay. Heads, activity data, keep checking. There we go, that's gone. They've gone now, right? I've still got some negative values, so I need to get those too as well. So it won't have removed the numerical value, the negative values, because they are technically numeric. So I need to subset my data in order to remove those. So remember back all the way back in week 4, we learned how to subset our data. The way I'm going to do it is just like this: data, data is going to be activity data. I'm going to call my activity, I'm going to make a conditional statement here, activity data, and I want the activity to be greater than or equal to 0. Don't forget your comma, because you want all of the rows, okay? If you don't put your comma in here, you'll get an error. Let's do that. Right, so I'm now down to 260 rows from 300. Let's just make sure there are no negative values in here. This is looking good. Okay, I think we're there, aren't we? Right, so in the book, I have a bit of a side quest looking at some possible visualization here, because you can't visualize two factors at the same time with a box plot, or you can, but it's very difficult. So I look at an an interaction plot for the activity, and then I also look at a heat map. So I'm not going to do that here. I'm going to let you fiddle around with that. I'm going to skip straight to what we're really interested in here, is this two-way ANOVA. Okay, form two-way ANOVA. And remember why we're doing this. We're interested in looking at the combined impact of both the pH and the temperature variables on the activity, and also we're interested in learning something about how those two things might interact with each other as well. Okay, so that's dead easy to do. It's almost the same as a one-way ANOVA. Now we've got all of our data cleaned and ready, we can do, let's make a new variable called activity AOV, and we're going to, again, it's the same thing pretty much, activity, except when I put in my my factors, I need to put them both in, okay? And the way I do that is with, weirdly, an asterisk. I want temperature. I've just spotted an error. I put in an uppercase H here, but I know my header is actually lowercase. So if you don't get the case right for your factors, that will be a problem, so be careful. I've also got to feed it my data frame, activity data. Control and enter. Right, I've got my ANOVA model now. And in the same way I would do it for a one-way ANOVA, I would use summary to check it out. There we go. Right, so this is different from my one-way. My one-way, I only had one line in here, which would have just been, well, if you remember for the zebrafish, it was just concentration PC, and then my residuals. Here, I've got the independent effects of each of those factors. So this is pH on its own, and I can see I've got a p-value which is way less than 0.05. So there is a significant difference in activity values in relation to pH. Same for temperature. Again, it's not so low this time, but it's still less than 0.05. And then I've got this extra row, pH colon temperature, and that actually tells me that there is something of one factor that is dependent on the other factor. So there's some relationship between the factors themselves. A change in one will yield a change in the other. We don't know what that change is, of course. That's why we're going to do a post-hoc test. But now you've definitely got some significant results from your two-way ANOVA. You can then proceed just in the same as a one-way. You can then do your post-hoc test. I'm going to use Tukey HSD again. And I am going to do Tukey result. HSD, Tukey with a capital T and then a capital HSD. I'm going to throw in my activity, AOV, and then I'm going to hit Control and Enter. Okay, I've got an error. What have I done wrong? Okay, I had some sort of gremlin then. I didn't like that at all. I don't know what was happening. So I actually reopened my project. So if you get an error and you think, there's something really weird going on here and I can't understand it, the first thing to do is go over to the top right and just reselect the project and then run everything again. And it seems to have worked this time. So I don't know. It's good that you see that sometimes we get errors as well. But the result is this massive table here. Let me show you this. This is my Tukey HSD result. So I've got pairwise comparisons for each independently for pH between all of my pH groups, then for all of my temperature groups, and then I've got all the possible permutations for my combinations of pH and temperature as well. So this is quite a large table. The values that I'm really interested in are my P adjusted values here at the end. So you can see in the case of pH, it was the groups 9 and 7 were the only one that wasn't significant, it seems. There's a significant difference in pH for the activity values between 7 and 5 and 9 and 5. Again, for the temperature, I've got p-values here. 2 of them are significant. And then I've got loads of significant results for my pH and temperature interaction table. So there's a lot here, and it's sort of exaggerated, really. I've deliberately designed a data set where there would be lots and lots of significance here. That will not always be the case. So there'll probably in future, when you encounter a real data set, you really have to look through these interaction comparisons and find the ones where there is a significance. Okay, there seems to be a lot of significance across the board here. Okay, so that's pretty much it for this week. There was one little thing which you're going to need to know in order to complete your summative tasks this week. So well done if you made it to the end of this video. This is for you. I need to answer the question. I think the question in the summative and the formative is the same, actually. I'm asking, after you performed a Tukey on a similar, very, very similar data set, not the same one, you'll have to get a different data set. What is the largest absolute difference in my interaction table here? Okay, so absolute means I don't care if it's negative, I just want to get the largest difference. And I want to know which is the biggest value. Okay, I don't know which, I don't care which group it belongs to, or sorry, which comparison groups it belongs to. I don't care what the p-value is. I just want you to quote one of these numbers to 4 decimal places to prove to me that you are capable of doing a two-way ANOVA in R. Okay, so my last 2 lines, I'm going to need to get a hold of my pH temperature interaction table. Now at the moment it's in a horrible list format within my Tukey result. So to get a handle on it, I'm going to convert it into a data frame, right? So let's do that first. And the way I do that is I'm going to call it Tukey_df, and I'm going to use the as.data.frame .function. Is that right, data? Yeah, that's right. And I'm just going to get my Tukey result, and actually to call it I need to do a double brackets, a quotation mark pH temperature, and that's just calling that table out of my list of tables. It's a bit messy, I know, but that's the best way to do it. And you can see here, if I actually print this out, it should look exactly the same. It just means I can handle it a bit better. Oh, actually, I've done something wrong. I spelled temperature wrong. Ha! Temperature. There we go. That's better. Now let's get the max absolute value. So I'm just daisy chaining those functions together, and I'll do it on my Tukey diff column. And there you go. This is the value I need. Okay. I will quote this to 4 decimal places in my test to get full marks. All right. Well done, everybody. I will look forward to seeing you next week.